Modern web apps live and die by navigation. If your pages feel slow, confusing, or disconnected, users bounce. But when routing, data loading, and transitions are all done right, everything feels instant, polished, and professional. And that's exactly what this React Router crash course is all about. In this crash course, you'll get hands-on experience with React Router version 7. You'll learn how routing works, how data loading fits into navigation, how loading and error states are handled, and how to build smoother user experiences from the start. Your instructor is Zach Taylor. Zach is a software engineer who has been building web apps since 2011. He studied computer science and machine learning and is passionate about teaching developers how real-world systems are built. Now he's here to guide you through the fundamentals of React Router. Before we jump in, there's a bonus that you don't want to miss. We're giving away free access to Zero to Mastery's Discord community, where you can connect with Zach, ZTM mentors, and thousands of fellow developers learning alongside you. Normally, this is reserved for Zero to Mastery Academy members, but for a limited time, we're giving it away completely for free. The invite link is in the description down below. All right, are you ready to get started? Let me hand it over to Zach so that you can start learning React Router. Enjoy.
This course is all about the web framework React Router. Yes, you heard that right. React Router is a framework. For those of you familiar with the React ecosystem, calling React Router a framework might sound odd. For those of you who are unfamiliar, don't worry. We'll learn all about the exciting history of React Router in an upcoming lesson. For now, let's focus on what we're going to learn throughout this course. React Router is a modern web framework. Learning React Router will not only help you build better web apps, it will also teach you a lot about the web platform. We'll start the course by learning the basics of routing. Each route in a React Router app defines a segment of the URL as well as a section of the UI, including all the data dependencies of that section. When you nest routes inside of each other, it enables you to build UIs that load quickly and are super simple to reason about. UIs built with nested routes are also highly resilient to errors in both your application code and in the network. We're also going to learn how to use Tailwind to style a React Router app. Tailwind is a super popular CSS framework, and it's used by a lot of companies to style their sites. It's a super in-demand technology, and it pairs really nicely with React Router. Next, we'll learn how to set up a Postgres database and how to connect to it with Prisma. Prisma is a very popular ORM that allows you to easily create tables in your database and then interact with those tables with TypeScript. At this point, we'll be jumping into the master project, which is the React Router Recipes app. We'll start by learning the basics of HTML forms and how React Router allows you to enhance forms with JavaScript by replacing the native form element with React Router's form component. With React Router's form component, you go from a plain old HTML form to a JavaScript enhanced form that behaves the same way but without reloading the entire page, giving the user a much better experience. This approach to forms is great for you, the developer, as well, because once you learn how HTML forms work, you already know how React Router forms work. There's very little extra React Router specific stuff to learn. Of course, HTML forms only allow you to submit one form on the page at a time, because HTML forms are actually modeled as navigations and the browser can't navigate to more than one URL at a time. So this is why React Router has the API called fetchers. It still behaves like a plain old HTML form, but you can actually submit multiple fetchers at once, giving your site more of an app-like feel. Once we know how to write forms in React Router, we're going to introduce a library called Zod for validating our form data on the server in a type-safe way. At this point, we'll dive into authentication and authorization. We're going to start by learning the foundations of authentication, cookies and sessions. These two concepts form the basis for our entire authentication system, so we're going to dive in deep and learn them well. And once we have that foundation, we'll implement a magic link authentication system. Magic links are awesome because they don't require the user to have a password. Instead, they just click a link in their email to log in. This means that we'll also learn how to send emails in React Router. We'll use a service called Mailgun to send emails, and we'll create the email content with React on the server. Once we have magic link authentication in place, we'll learn how to do authorization in React Router. While authentication is the process of identifying a user, authorization is the process of allowing or denying access based on who that user is. Authentication will also open up an opportunity to learn how to use middleware in React Router. Middleware is a great API that allows us to run code before and after the response is generated for a URL path. After we have our authentication system set up, we'll get to work on the most complicated page of the app, the recipes page. As we work on this page, we'll learn several cool concepts and techniques, including optimistic UI, input focus management, and the link prefetch API. We'll then learn how to upload files and store them on the server. This process will teach us about specifying different data formats with the content type header. We'll then learn about different approaches to building modals in React Router. React Router allows you to easily store state in the URL path or in search parameters. So we'll talk about the trade-offs between keeping modal state in the URL versus in React. Next, we'll learn about resource routes in React Router and how they allow us to return different media or MIME types. This enables us, for example, to control the theme of the site by defining a resource route that returns CSS. Finally, we'll learn about caching in React Router. React Router's default approach to caching is really cool because it leverages the browser's built-in cache. You can cache data from your loaders by returning a cache control header, which tells the browser to hold on to that response for the amount of time that you specify. The next time your page needs that data, it can just grab it from the browser cache. This means that you don't have to set up tools like Redux or React Query if you don't want to. Once we're done building the master project, we'll finish things off by learning how to test React Router apps with Playwright, an end-to-end testing framework. Then we'll talk about deployment and deploy our app to fly.io. By the end of this course, we'll have deployed a fully featured app with React Router. I can't wait for you to get started. What's up, everyone? In this course, we are going to learn how to build web apps with React Router. React Router is a multi-strategy router for React. The minimal use case for React Router is as a tool for client-side routing. If you're familiar with the React ecosystem, this is likely what you've used React Router for before. Now, as of version 7, you can also use React Router as a full-stack framework, in which case you can think of it as a competitor to Next.js. This is React Router at its full potential, and it is the way that we'll be learning React Router in this course. Let's talk prerequisites. As you might suspect, React Router apps use React for building the UI. So some previous knowledge of React will be useful for this course. React Router apps are also typically built with TypeScript, though you can use JavaScript without types if you really want to. We'll be using TypeScript in this course, so some prior knowledge there will be helpful. Ultimately, though, I think you'll be fine taking this course even if you've never used React or TypeScript before. So who built React Router? React Router was created in 2014 by Michael Jackson and Ryan Florence. It started out as a client-side routing library, but it has grown a lot since then. Its history is also very intertwined with a web framework called Remix. In 2021, Michael and Ryan released Remix, which at the time was a new full-stack React framework, a competitor to Next.js. Remix was built on top of React Router version 6, and it was Michael and Ryan's vision for what React Router could look like as a full-stack framework. In October of 2022, Remix was acquired by Shopify. And then in May of 2024, Remix and React Router merged into the same project, which was released as React Router version 7. Michael and Ryan and a few others are now employed by Shopify to continue working on React Router. They also work on a completely new framework, which is also branded as Remix, but that is its own separate thing and it does not use React. They're calling it Remix version 3, but really it's version 1 of a completely new Remix. If that history confuses you, you're not alone. Here's a full picture of the history of the React Router and Remix projects. Hopefully this gives you a good sense of how these projects intertwine. In this course, you will learn React Router, which is the red part of this diagram, as of version 7 and beyond. In this lesson, we're going to answer the question, why should you learn React Router? React Router has been around for a long time. It's been the de facto routing library for React applications since it was released in 2014. Thousands of apps have been built with React Router, so whether you're working on an existing React app or building something completely new, knowing React Router will put you at an advantage in the job market. Speaking of the job market, another primary reason you should learn React Router is that it places a strong emphasis on web fundamentals. One of the React Router team's core philosophies is use the platform. This philosophy shows up all over React Router, from the way you write forms to the way you add styles to the way you cache data in the client. If the web platform already knows how to do something, React Router enables you to take advantage of that. This philosophy of using the platform also has far-reaching implications for your personal web development journey. The web platform is awesome, but during the last several years, the web development community has largely forgotten many of the basics of the web. Many web developers today never learn basic things about how the web works, including forms, HTTP, cookies and session data, and basic browser behavior. React Router developers understand all of this and more. Because React Router is so focused on web fundamentals, it's impossible for you to learn React Router and not also learn a lot more about how the web works. You might be surprised to see how often we reference MDN's web documentation instead of React Router's own documentation throughout this course. A lot of React Router's APIs are really just existing web APIs. This means that all of the skills you gain by learning React Router are transferable. If you work on a web project that doesn't use React Router, a lot of your React Router knowledge will carry over. This makes the time you invest in learning React Router extremely worth it, because you're not just learning a new web framework, you're learning the web itself. Now let's get a bit more technical. React Router creates good user experiences by default. Errors, network latency, interruptions, and race conditions are all things that developers need to think about in order to create a great user experience, and yet most seldom do. These are hard problems to deal with. React Router knows this, and it has many built-in features to make your life easier when it comes to dealing with these more difficult aspects of web development. Finally, React Router offers a lot of flexibility. You can scale it up or down as much as you need. If you only need a client-side React app, great. React Router can handle that. Want to server render your pages? React Router can handle that too. You can also build apps with a mix of both approaches. You can create server-rendered pages with absolutely no JavaScript if you want to, alongside highly interactive pages with no overhead. Hopefully by now you have a sense for what React Router is and why you'd want to use it. I'm excited to get started. So, before we go any further, I need to take a minute to explain something. As we've already learned, Remix was built by the team that built React Router. And not only was it built by the same team, it was also built using a lot of the same code. Now, over the years since Remix was first released, the Remix team has been adding a lot of features from Remix to React Router. Eventually, it got to a point where they had moved so many things from Remix to React Router that the projects were essentially the same thing. And as of November 22nd, 2024, this is actually the case. Remix and React Router are the same. Here's a little visual of the history of the two projects that I pulled from one of the Remix team's blog posts. React Router had gone through 6 major versions, and Remix had gone through 2 major versions before they merged the projects into the same thing. So what would have been Remix version 3 was released as React Router version 7 in November of 2024, and that's where we remain today. Now, the Remix team will not be getting rid of the Remix name or brand. That's going to stick around, and they plan on adding things to Remix in the future. But for now, Remix is taking a little nap while we're on React Router version 7. So what does this mean for you? Well, if you're starting a new Remix project after November of 2024, you should create it using React Router version 7 instead of Remix. If you have an existing Remix project, you should upgrade it to React Router version 7. And in this course, we will create our application using React Router version 7 since that's the latest version of Remix. Now, many things in React Router version 7 are the same as they were in previous versions of Remix, so you might still see code being imported from Remix throughout the course. Those imports right now are incorrect. You should be importing everything from React Router for now. In this lesson, we're going to walk through the master project that we'll be building in this course. This is the app that we'll be building. We're calling it the Remix Recipes app because it's built with Remix and it deals with recipes. If you're not logged in, this is what you'll see when you arrive at the site. The home page is called the Discover page, and it allows you to see the recipes that users have created. If you click into one of the recipes, you'll see the details of that recipe, including the list of ingredients and the instructions on how to make it. When we build this page, we're going to learn about the browser's built-in caching mechanism. Let's open up the Network tab. When a user visits this page directly, the entire page has to be downloaded, which takes 5.8 kilobytes, as you can see here. However, we're going to learn how to tell the browser to cache this page. So if we were to visit this page again, the browser simply asks the server if anything has been changed. It hasn't, so the response size this time is only 310 bytes. This small improvement makes this page load much faster for users on a slow network. You'll see throughout this course that Remix is obsessed with the Network tab because the network is where you can create the most impact for your users. We also have a Settings tab over here. The Settings tab allows you to change the theme of the site, even when you're not logged in. This is achieved through the use of cookies. By the end of the course, you'll have a solid understanding of what cookies are and how to use them effectively. The last button here on the left is the Login button. Our app will use Magic Link authentication, so no password is required to log into the app. You just input your email address, and then you'll get a link in your email. When you visit that link as a new user, it'll ask you for your first and last name. If you try to sign up without a name, you'll receive an error message. Now you might notice that we get this spinner up in the Browser tab when we click Sign Up. This is because the Sign Up button is part of a web form, and forms refresh the page by default. Could we have avoided refreshing the page here? Of course, but the point is we don't necessarily need to. Remix enables you to use default web behavior in cases like this. You can start with a basic web form, and then later you can come in and add JavaScript to enhance the user experience if you want. Let's go back to the login page and sign in as an existing user. When you sign in, you're taken to a new section of the site, the App section. This is where the main functionality of the site can be found. We'll walk through this section in the next lesson. In this lesson, we're going to walk through the main app portion of our Remix site. The first tab on the left here is the Recipes tab. This is where you can manage the recipes that you have stored. Your list of recipes is over here on the left. You can enter a search query here to narrow it down. Notice how the search state is stored in the URL. This is cool for a couple reasons. One, you can refresh the page and nothing changes. This means that if this were a public page, you could share this URL with someone and it would take them to the page in this exact state. Another reason this is cool is that because the state is encoded in the URL, you now have access to all the tools that URLs enable. For example, you could cache the response for this query separately from the full list of recipes, which would enable you to improve the speed of the search for common queries, for example. When you click a recipe, you see all the details of that recipe show up on the right side. And that includes options to upload a new image or to delete or save the recipe down here. Now, this recipe view is actually much more impressive than it seems at first glance. Let's create a new recipe to see what I mean. Let's start by entering a new name and time. Notice how the name and time update automatically in the left side after a few milliseconds. This happens because we save as you type, but we debounce the name and time inputs so that you're not overloading your server with requests, thereby speeding up your app. Now let's add an ingredient. Notice how when I hit enter, I'm immediately taken to a new line and the amount input is focused. This enables me to quickly enter ingredients without having to think about where my cursor is. Then I can add some instructions down here. And now when I'm done with that, the save button is technically optional at this point because everything has already been saved automatically by JavaScript. But it's just there as another option. The save button is actually necessary if you want to add a new image for the recipe. To add a new image, just drag that image here and then click Save. Now, this is a pretty smooth user experience on my fast local network. Remix really comes to life, though, when you start messing with the Network tab. Let's create another recipe, and then let's open up the Network tab and simulate a slow 3G network. This is the type of connection you'd have if you were on a subway or in some other area with a bad internet connection. Let's see how the page does under these conditions. I'll start by popping this out so we can see the whole page. Now let's enter a new name and time. Notice how the name and time update in the left just as quickly as on a fast network. This is due to something that we call optimistic UI. Instead of waiting for the network request to complete before updating the UI, we can just assume that the request will work and update it immediately. If the request were to fail, the UI would automatically be reverted. We'll learn all about optimistic UI in this course, and we'll see just how simple Remix makes it. Now let's add some ingredients. I'm also able to add ingredients just as quickly as on a fast network. Notice how we also have a little bit of custom pending UI for the ingredients as they are being saved, too. The background is just slightly gray. Deleting ingredients is also immediate on a slow network. And if any of those deletions were to fail, they would automatically pop back in once the network request is complete. Now, if I were to add some ingredients and then delete them before they've been saved, the ones that I deleted that hadn't been created yet will pop back into the UI. Remix takes care of this for us. Remix's patterns ensure that the UI will always be correct eventually. You just might have to give it a couple seconds in these slow network conditions. A lot of developers don't even think about how their app will be used on slow networks, but Remix puts it front and center. Not only does Remix enable you to build optimistic UI in a simple way, but it also takes care of a lot of common bugs caused by network problems for you. Your app is only as good as it is for your slowest user. Remix ensures a better user experience for all your users, no matter where they might be or what device they might be using. We've also added a couple more niceties for slow networks. When you click a recipe link, 3 dots will show up after the name if the request is taking too long. The nice thing about this UI pattern is that you can still see the recipe on the right. You're not forced to stare at a blank area with a spinner. In Remix, this kind of UI is the default. You'll rarely need to make the user stare at a blank UI with a loading spinner. In fact, you probably never will. We also have these pulse animations for the links in the left navigation. Let's go back to a normal network speed. And then we'll continue looking through the rest of the app tab in the next lesson. In this lesson, we're going to finish our walkthrough of the master project. The next tab up here is the Pantry tab. This is where you can organize food items that you already have. The app will use this information to generate a grocery list of only the things that you don't already have. The UI patterns on this page are similar to the recipes page, but quite a bit simpler. This will actually be the first page that we build in the app. You can create new shelves, update the name of a shelf, add items, delete items, and delete shelves. And of course, this all works just as well on a slow network. The final tab is the Grocery List tab. This tab is empty right now because we haven't created a meal plan. To do that, let's go back to the Recipes tab, and let's click on a recipe that we want to make. To add it to the meal plan, we just click this little calendar icon next to the name. This opens up a modal where we can choose how many times we want to make this recipe. Then we click Save. You'll see that the recipe name updates to have a ×2 next to the name. And we can now filter our recipes down to just the ones in our meal plan with this button up here. Let's add one more recipe to the meal plan. So now our meal plan has these 2 recipes. Now, if we go to the grocery list page, we'll see a list of all the things we need in order to make the recipes in our meal plan. Each card here tells us the name of an ingredient, how much we need, for which recipe, and what that recipe multiplier is in our meal plan. At this point, you could log into the app on your phone and take it to the store. The UI will dynamically adjust to a mobile view. Now, as you pick up items in the store, you can check them off on your phone. Once you've made it through the list of items, you'll see this empty state again. Back in desktop view, let's go back to the pantry page. You'll see that the app added all of those items to your pantry as you checked them off. And they're here in this new shelf named after your grocery trip. You can now go back to the recipes page and clear your meal plan to start over. Now, are you ready for the part that will blow your mind? Let's open up the developer tools and disable JavaScript. You'll notice that every critical feature of the app still works. We can still navigate around. We can still add new shelves to the pantry. We can update the name and save it with that button. We can still add items. We can still delete the shelf. We can still create and edit recipes. We still get error messages if something goes wrong. And so on. Now, I don't imagine that any of your users will have JavaScript disabled in their browsers. So why is it really so cool that we can do this with Remix? Well, with few exceptions, we didn't intentionally make our site work without JavaScript. That's just a side benefit to using Remix. The fact that the site works without JavaScript benefits users because the site still works if their network is so bad that the JavaScript fails to download altogether. And it benefits you, the developer, because it teaches you how the web works. This all goes back to that Remix philosophy of using the platform. Every feature that we build in Remix starts out as nothing more than default web behavior. Then we add JavaScript and Remix fanciness to get that awesome app-like user experience. Throughout this course, you're going to become really familiar with how the web works. Over 90% of the things you learn building with Remix can be applied elsewhere in your web development career. If you want to understand the web better and take your skills to the next level, you're in the right place. I'll see you in the next lesson. In order to follow along in this course, you'll need NodeJS installed on your computer. So that's what we'll do in this lesson. Node.js is a JavaScript runtime, which means that it allows us to run JavaScript code. There are several other Node.js runtimes that exist, including Deno and Bun, but we'll use Node.js in this course. The easiest way to install Node is to go to the NodeJS website. Here, you'll see that the latest version is 18.16, so that's the one that we'll use. Choose the appropriate installer for your operating system. I'm on a Mac, so I'll choose this one. Save. And then once that's finished downloading, click this to open it. This will open up the Node.js installation wizard. Accept all the default settings, and then click Install. I already have Node installed on my computer, so I will install another copy. Once you've finished installing Node, open up a terminal window. You should be able to run node version to see which version of Node you have installed. The installer also installed the npm package manager for Node, so you should be able to run npm version to see which version of npm you have. If both of these commands work, then you successfully installed Node on your system. In the next lesson, we'll set up our Remix project. In this lesson, we're going to create our React Router project with the React Router command line interface. To do this, let's open up a terminal window, and then we can create a new project with npx create React Router at latest. Now, it might ask you if you want to install the Create React Router package, and if it does, say yes. Now, the first thing it asks is where you want to create the project. Since we're building an app with React Router dealing with recipes, let's call it React Router Recipes. Next, it asks if you want to initialize a new Git repository. You don't have to choose yes if you don't want to use Git, but React Router recommends it, so let's say yes. Next, let's say yes to having React Router install our dependencies for us. Once everything is installed, you can cd into the project directory and then run the project with npm run dev. React Router uses Vite to run its development server, so you'll find the dev server by default located on port 5173. If you go to that port in the browser, you'll see that the project is running. In the next lesson, we're going to start getting familiar with the React Router project code. In this lesson, we're going to create our React Router project with the React Router command line interface. To do this, let's open up a terminal window, and then we can create a new project with npx create React Router at latest. Now, it might ask you if you want to install the Create React Router package, and if it does, say yes. Now, the first thing it asks is where you want to create the project. Since we're building an app with React Router dealing with recipes, let's call it React Router Recipes. Next, it asks if you want to initialize a new Git repository. You don't have to choose yes if you don't want to use Git, but React Router recommends it, so let's say yes. Next, let's say yes to having React Router install our dependencies for us. Once everything is installed, you can cd into the project directory and then run the project with npm run dev. React Router uses Vite to run its development server, so you'll find the dev server by default located on port 5173. If you go to that port in the browser, you'll see that the project is running. In the next lesson, we're going to start getting familiar with the React Router project code. As you probably know, technology is always changing and it's changing fast. In fact, technology changes so fast that if you're not constantly keeping up with the latest trends, you can quickly fall behind. React Router is no exception to this rule. The advantage that you have by learning React Router right now in this course is that you are learning the latest that React Router has to offer. This puts you ahead of developers that choose not to keep up with trends, even though those developers might be more experienced than you. However, it's also good to learn React Router's history. One of the major reasons that experience with the technology is valuable is that through your experience, you gain an understanding of that technology's evolution and how it arrived at its current state. This gives you insight into why things are done the way they are, and understanding the why is a key characteristic of a mature developer. React Router uses semantic versioning, which is a standard way to define version numbers for software. Under the semantic versioning system, version numbers have the format a.b.c. A is called the major version, and that number is incremented when the software gets a backwards incompatible API change. B is the minor version, which is incremented when the software gets additional functionality but in a backwards compatible manner. And then C is the patch version, which is incremented when the software gets a backwards compatible bug fix. Now, while React Router does use semantic version numbers, its approach to releasing new features might be a little bit different from what you're used to. When the React Router team develops a backwards incompatible feature, they don't wait until the next major version to make it available to you. Instead, they keep the existing major version, then increment the minor version and make a breaking change available behind a future flag. You can set future flags in your React Router config file under the future attribute. For example, if you were currently using React Router version 7, there would be a future flag for middleware, which you could turn on with v8 middleware is true. So with this future flag set in your React Router config, the next time you run your app, React Router will allow you to use the v8 middleware API, even though you're still on version 7. This is a really smooth approach to feature development because it allows you to gradually incorporate new features with future flags as they become available. This will keep you up to date with the latest React Router features with minimal overhead. If you ever need to customize how React Router sends responses from the server or how it renders in the client, you can use React Router's entry files. Now, these files are hidden by default, but you can reveal them by opening up a terminal and running npx react router reveal. That command created these two entry files. Let's first take a look at entry.server. The default export of this file is a function called handleRequest, and this is a function that React Router will call when generating a response to send to the client. Now, it's not too important to know exactly how React Router forms its responses, only that you can customize any part of it by editing this file. React Router gives you full control over how it generates HTML responses, which can come in really handy. For example, later on in the course, when we learn about caching, we'll update this file so that it sends some extra response headers in situations when caching would be appropriate. Now let's look at the entry.client file. This file is the entry point for the client or browser build. It's the first thing that runs when your JavaScript gets to the browser. By default, this file is pretty simple. It just uses React's hydrate root API to hydrate our app. Now, if you're not familiar with React hydration, the gist of it is that hydrate root takes the markup that our entry.server file rendered and attaches React event listeners to it. This means that when React hydrates, we're essentially running a single-page app in the browser. So with React Router, we can get all the benefits of single-page apps in the client while also having the benefits of server-side rendering. In order to use React Router effectively, you have to understand routes. Routes are the fundamental building blocks of any React Router app. In React Router's framework mode, a route is a file that defines the UI to display when a user visits a particular URL, the data needed to render that UI, and then handlers for data mutations, among a few other things. Now, you match route files to URL segments in the routes.ts file. So if we were to write this in our routes.ts file, we're saying that our app would use the UI, data, mutation handlers, etc. from the route file at routes/sales.tsx whenever the user visits the /sales URL. Now, a route file can define several exports, so let's take a look at this example sales.tsx route file. So first we have the default export, and this is a React component, which is the UI that will be shown at the /sales URL. The data that this component needs to render is returned by the loader. Now the loader runs on the server only. The action also runs on the server only, and it handles server-side data mutations, like form submissions, for example. We also have several other possible exports, and I haven't listed all of them here, but here are some of the notable ones. So we've got the client loader and the client action, and these mirror the loader and the action, but they run on the client instead of the server. We also have the links export, and this export allows you to add link elements to the page. So, for example, this would be useful for rendering style sheets. We also have an error boundary export, and this is a really cool feature of React Router. So, if there's an error that happens anywhere on this route, React Router will replace the default export component with this error boundary component. We also have the meta export, and this returns metadata about the route, which will be added to the head of the page. And then the last one that I want to note is this headers export. So the headers export returns headers to add to the HTTP response when the user visits this route. So what does React Router do with these route files once you've defined them? Well, when you build your project, React Router will look at your route modules and then split them up into two builds, one that is run on the server and one that runs in the browser. So there are two important things I want to note here. First, the loader and the action exports only go to the server build. That means that you can write server-side only code in your loaders and actions. For example, you can talk to your database with a tool like Prisma. The second thing I want to note is that the component goes to both the server and the browser builds. This enables React Router to server render the page when the user initially visits your site and then hydrate the UI on the client. So you get the benefits of server-side rendering, but your app behaves like a single-page app once it reaches the browser. All right, that's all I want to say about routes for now. So hopefully that gives you a good idea about what routes are and why they're so important in React Router apps. In this lesson, we're going to learn how to do basic routing in Remix and React Router. Routes are at the core of everything Remix does, so it's important to understand them well. Now in Remix and React Router, you configure your routes in the routes.ts file. This file allows you to map URL segments to route files in whatever way you see fit. Now right now, we just have one route here, and it's defined using the index function from React Router. We can ignore this for now. I'll explain the index function more later on. For now, we just need to know that we can create new routes by adding them to this list. So let's create a new route at the /discover URL. So we do this with the route function, and then we say the name of the URL that we want the route to be at. So we'll say /discover. And then we give it the name of a route file in our file system. So we'll just put a discover.tsx file in our routes folder, and that will be the route file for the route at this URL. So we haven't created this file yet, so let's go ahead and do that. So now we tell a route to render content at its URL by defining a React component as the default export. So for now, it can just be something basic like a header and some text. Something like this. So now if we were to run our app with npm run dev, we can go to /discover in the browser, and here we see that discover component that we just created. Let's define a couple more routes. So back in our routes.ts file, let's add a app and a settings page. Then let's go ahead and create the route files that we need for both of these routes. And let's add some basic content to them, just like we did for the discover route. Now, we might need to restart our server. And then if we come over to the browser and go to /app, we'll see the app page. And if we go to /settings, we will see the settings page. Cool. Now we know how to do basic routing in a Remix or React Router app. In the next lesson, we'll go a little deeper and learn about nested routes. In this lesson, we're going to learn about nested routes in Remix and React Router. Now, nested routes are called nested because they nest their UI inside of another route. So, for example, on the settings page, we might have some different sections for app settings versus user profile settings. So we would want some navigation right here, and then the specific settings to show up down below. Let's start by adding a couple links to the settings page so that we can navigate between the different setting types. Now, React Router has a link component that does client-side routing, which means that the page won't refresh when we click the links. So now back in the browser, if we were to click on the profile link, we're taken to settings/profile in the URL, but we get this not found error because we haven't defined that route yet. So to nest the app and profile settings inside the main settings page, we can add a list as the third argument to the settings route, effectively making it a parent route. And then we put the route definitions for the children, our app and profile settings pages, inside this list. So we can say route app, and then the file that we'll put this in is routes/settings/app.tsx. And I just find it convenient to put nested routes inside of a folder with the same name as the parent route, so that's what we're doing here. Now let's put the profile route in here as well. So now we have app and profile settings routes nested below the parent settings route. Now, one thing that's important to point out here is that for nested routes, you do not put a beginning slash like you do for these main routes up here. Instead, for nested routes, you just leave the slash off. Now let's go ahead and create these new route files. So let's create that folder. And then let's create the app and profile settings route files. And then inside these route files, let's just put some basic content like we've done for the other routes that we've created so far. Now, usually when you create new routes, it's a good idea to restart your server just in case it didn't pick up the changes. But now if we go back to our settings page and click on the profile route, we're still taken to settings/profile, and this time we didn't get an error. However, the content that we defined in the profile route doesn't show up anywhere on the page. Why is that? Well, since nested routes are supposed to be rendered inside their parent routes, we have to tell Remix exactly where inside the parent route it should go. So let's come to the settings route, and then down here we can tell Remix to render the nested routes right below the navigation with the outlet component. The outlet component basically tells Remix this is where you should render any nested routes if they exist. So now if we come back to the browser, we'll see the profile settings are being displayed down here. And if we click on the app link, we see it's replaced with the app settings. So we can now navigate between the two. Now the cool thing about the outlet component is that it's aware of which route the user is at. So when we go to settings/profile, outlet knows that we want to render the profile route. And when we go to settings/app, it knows that we want to render the app route. Cool. Now that we've learned a little bit about routing, we're going to learn about one of the special routes in a Remix or React router application called the route route. We'll do that in the next lesson. In this lesson, we're going to learn about the route route. By way of introduction, let's learn about matched routes in Remix. In Remix, every page has one or more matched routes. Given a URL, a matched route is a route that participates in rendering the page at that URL. If we were to draw all of the routes in our app as a tree, it would look like this. So, given a URL, you can find the matched routes by starting from the route route and going down the tree. So when the user visits the empty path, the matched routes are root and index. When the user visits the settings/app page, the matched routes are root, settings, and settings/app. As you can see, the route route is special because it's a matched route for every URL in your app. This means it allows us to define things that apply to every page in our app globally. Let's take a look at the root route in our app. It can be found here in the app directory. The root route defines a default export and a layout export. The layout export is a little hard to explain without more context, so for now just understand that when Remix renders the root route, it passes this app component as the children prop to the layout component. Right now, this default export just returns the outlet. The outlet functions the same way in the root route as it does in our settings route. It just renders the appropriate nested route. So when we're on the Discover page, we'll see that content right here. And when we're on the settings page, we'll see that content. Now, as I already mentioned, the root route enables us to add content and logic that apply to every page of our app because it matches on every page. So for example, we could add some global navigation here. Let's wrap this in a fragment. And then let's add some links for each of the main pages of the app. Now, if we go to our app in the browser, we'll see all these links up at the top, and we can click between them. So that's all we need to learn about the root route for now. The root route is special because it matches every page of your app, and therefore it allows you to define your app layout and apply global logic and UI. In the next lesson, we're going to learn about each of these components that you see rendered here. These are special components that Remix gives us to do certain things. In this lesson, we're going to take a closer look at the content of our root layout. Specifically, we're going to learn about each of these components that we get from React Router. Now first, I want to point out that we're rendering the full HTML document here, including the head and the body. This is nice because it means that you have full control over the content of your pages, and React Router isn't magically injecting anything into the document that you can't see. Alright, the meta, links, and scripts tags are all sort of related, so let's discuss scroll restoration first. Scroll restoration is React Router's way of emulating a default browser behavior. As we go on in this course, you'll see that React Router does this a lot. It takes a default browser behavior and then emulates it with JavaScript to give the user a better experience. So the behavior that React Router is emulating here is scroll restoration. So if you don't know what scroll restoration is, let's say that we come to the cache control page here on MDN and then we scroll down a bit. Now if I go to a new page and then I click the back button, I'm automatically taken to the place in the page that I was at before. If your app does client-side routing with JavaScript, you lose this behavior because in that case, JavaScript has taken over control of navigating between pages. So React Router's scroll restoration component mimics that default browser behavior with JavaScript, allowing you to have both client-side routing and that scroll restoration behavior. Next, the scripts component here renders links to all of the JavaScript files that the page needs so that the browser can fetch them and execute them. Next, let's talk about this meta component. Now, if we go to our home route, you may have noticed that there's a meta export here. The meta component in the root route renders any meta tags defined by meta exports for routes that match the current page URL. So here we're returning a title and a description. So the meta component back here in the root route will gather all the return values from meta exports and then turn them into HTML tags. Now, it would be good to include a title and description on all pages of our app. So let's move this meta export to the root route. Let's also change the title to React Router Recipes. Since that's the name of the app that we're building. Let's also change the description to Welcome to the React Router Recipes app. So now if we come back to our app, you can see that every page has React Router Recipes up here in the tab. Finally, we have this links component. Now this component deserves a bit more explanation, so we'll talk about it in the next lesson. In this lesson, we're going to talk about HTML links. And just to clarify, we are not talking about the anchor tag, which is used for creating hyperlinks on a page. In this lesson, we're talking about the link tag, which is used to link the current document to external resources, like JavaScript or CSS. You can see that in our app, we're using links for JavaScript resources down here. This is the MDN web docs, and it's a great resource for learning about web APIs. And this page is all about the link element. I think they give a good explanation here of what the link tag is. The link tag specifies relationships between the current document and an external resource. And it's most commonly used to link style sheets, but it's also used to establish site icons, among other things, like the JavaScript that you saw, just barely. They have an example right here of using the link tag for including a style sheet on the page. The rel attribute stands for relationship, and it tells the browser what the relationship this link is to the current document. So in this case, it's a style sheet. And then the href tells the browser where to go to get this resource. Now we're only going to focus on using link tags for style sheets for now, but there are many different relationships that you can specify on a link tag. If you scroll down a little bit, there's a link here, and this page tells you all the different link types. There's a ton of different link types, and if you scroll all the way down to the bottom, this is the style sheet link type that we're going to be focusing on. A couple other interesting ones include the module preload type, which tells the browser that this is a high priority item that needs to be loaded as fast as possible. There's also prefetch, which suggests to the browser that they fetch this resource in advance because the user is probably going to need it. And this is really nice for fetching resources on a different page in your app that you think the user might visit soon. In other words, it's really helpful for eliminating loading states on route transitions. There's a lot to know about links, and it's more than we can cover in this course. But if you're curious, I highly suggest reading the documentation here on MDN. There are some really interesting things about links that you may not have known before. So in this lesson, we talked a little bit about the link element. And in the next lesson, we're going to start using it to add style sheets to our app. Let's use links to add some style to our page. First, we need a CSS style to link. We can put this file anywhere we want. So if you don't have one already, let's create a styles directory here in the app directory. And then in that folder, let's create a file called index.css. Now, it doesn't really matter what we put in here since this is just an example of how to import CSS files into your app. So let's say H1, color blue, font size 2 rem. So to use this CSS file in our app, we first need to pick a route where these styles will be applied. Let's pick the Discover route. Now, Remix's Route API allows you to export a function called links in a route to include links to resources like CSS. So let's export that function here. And then let's type it. And now Remix expects this function to return a list of objects that conform to the link API that we learned about in the last lesson. So in the last lesson, we learned that to link a style sheet, we need to include the rel property, and that needs to be set to style sheet. And then we also need an href property. And the href needs to point to a URL telling the browser where to find the style sheet that we want to include. Now, since Remix uses Vite to build our app, we can get a URL for the CSS file index.css by importing it up above. So let's say import styles from, then we can use a tilde to reference the app directory, and then we'll say styles/index.css. And then to turn this styles variable into a URL string, we put $URL on the end. And that is a Vite convention to turn the styles variable into a URL string. So now we can use styles down here as the href. So now if we go to the Discover route in our app, you'll notice that the title is blue and the font size is bigger. Now something kind of interesting happens if we go to the app route. If we inspect the page and look at the head of the document here, you'll see this link where that index.css file is being included. And this is being included in the head by that links component in the root route that we learned about a few lessons ago. Now something kind of interesting happens if we go to a different route. So if we click on app here, you'll notice that that style sheet got removed from the head of the page. And so the styles are no longer applied to the title on this page. So why does that happen? Well, remember how in Remix each page has one or more matched routes? Well, Remix only includes the links on the page for routes that match the current URL. So on the app route, the Discover route doesn't match, and therefore its links are not included on this page. If we wanted to include the styles on multiple pages, we could either put the link in each route file where we want to use it, or we could go up a level in the route tree and put the link there. Since the root route matches every page, any links that we include in it will be global. In other words, they'll be shared across every page of our app. So let's open up the root route. And now if you created your project using React Router version 7, you'll notice that a style sheet called app.css is already being imported here, and it's being included as a style sheet in the links export. Let's open that app.css file. We're going to ignore what's in here for now, but at the bottom, let's add some styling for anchor tags. Now if we go back to the app, you'll see that every hyperlink on the page has that padding. And this even applies to these links down here on the settings page. This padding is being applied to every page of our app because we included that style sheet in the root route. Cool, so we've learned a little bit about how to include CSS files on a page in Remix. But let's talk a little bit about why Remix's approach to styling is so great. One of the major issues with CSS is that it's not always easy to tell which styles are being used on which pages, because we usually bundle all of our CSS files into one large file that is present on every page of the app. And another issue that comes with that is that if you change the styles on one page, you might unwittingly affect styles on another page. But in Remix, we explicitly import styles in each route. And by doing that, we're better able to tell which styles are used where and how a change to the CSS on one page will affect the CSS on other pages. Now, organizing your styles by route is really nice, but you might want to organize your styles by component instead. We'll talk about how to deal with that in the next lesson. When building apps with React, you'll eventually want to start splitting your UI into reusable components. Since Remix asks you to include styles at the route level, how should we organize component-level CSS files? That's the question we'll address in this lesson. Let's start by creating a couple components to use as an example. So in here, in our app directory, let's create a new folder called Components. And then in here, let's create 4 files. So we'll do header.tsx, header.css, and then we'll do the same thing for a paragraph component. Now in the header CSS file, let's add a .header class with these styles. So we're just changing the font family and making the header this dark gray color. Then let's copy this for the paragraph component. Change this to paragraph. And then let's also add a font size of 13 pixels just to differentiate it a bit. Then in the header component file, let's add a header component. So this just takes one prop children, renders an h1 with the class name header and those children inside. And then for the paragraph component, let's copy this, but change header to paragraph. And then change the h1 to a p. Then finally, in our index route, let's remove all of this content and just return a div with the header component and the paragraph component saying welcome home. Okay, so we're using our components here now, but we need to get the header component styles and the paragraph component styles into our index route. So how do we do this? Well, we have a few options, and we're going to go over each one and the trade-offs of each. So first, we could just import the CSS files into our index route here, and then include those files in this list of links. And this is nice because it keeps our CSS dependencies explicit, it's easy to tell what's being used where, and our styles are aware of the route lifecycle, so they'll get added and removed from the document as you navigate around. The drawback is that it's a lot of boilerplate to import the styles for every component you're using, make sure they're all included in the links export, and then do that for every route that you're going to use these components on. You might just not want to write all of this code every time you want to import and use a component. So the second option is we could import the CSS file in the component itself without the URL suffix that we did for our index CSS file. So that would just look like this. import./paragraph.css. And then in our header, we would just import the header file. Now, if we do this, then we can come over to our app, and we'll see that those styles have been applied here. And if we look down here in the elements inspector, we'll see that Vite has included these styles as style tags in the head of our document. So we've got the paragraph one here, and then we've got the header one down here. So that's how that works in development, but if you were to do a production build by coming over here and running npm run build, then Vite's going to build the app for production. And then in here in the build client directory, we have this assets folder. And then one of these index files is the file that Vite has constructed using those imports. So we have both the header and the paragraph styles in this file because Vite is just going to bundle every import of CSS into one file that you can then serve in your production app. So this approach avoids the boilerplate from just importing and using the links export. However, it makes it so that if we ever have to click to a different page, so notice in our app, if we click over here, the paragraph and header styles are still in the document, and that's because Vite now has control over our styling, so it's not aware of the route lifecycle anymore. And so because these styles are getting included on every page of the app, we're going to run into these problems that we talked about in the last lesson. It's hard to know which styles are used where, and hard to know how a change to CSS is going to affect the whole app. Now, an approach we could take to solve both of these problems while also not using the route links export is to use CSS modules. And Vite comes with support for CSS modules out of the box. So if we wanted to use CSS modules with our paragraph component, for example, we would just need to rename this to paragraph.module.css. And then in our paragraph component, we would import classes from paragraph.module.css. And then we would have to use classes.paragraph right here, since this is the name of the class in this file. So if we want to see what this looks like in our app, we can come here to the home page, look at our head, and we'll see that the paragraph style now, this class name looks different, and that's because with CSS modules, it generates a unique class name for every class. And that makes it so that your styles used from one component don't clash with styles from another component. So you could even name two components similar things, or use the same class name in multiple places, and they're not going to override each other. Now, the final approach that we could take is to use Tailwind CSS. Now, Tailwind is the approach that we're going to use in this course, so we'll talk about it more and set it up in the next lesson. In this lesson, we're going to get familiar with Tailwind by using it to style our main nav bar here. What we want is for the nav bar to line the left side of the page and for it to be green. So Tailwind comes with a predefined color palette for you to use if you want, but if you have specific colors in mind for your app, you can extend Tailwind's color palette with your own colors in the Tailwind config file. There's a specific shade of green we'll use in our app. So let's open up our Tailwind config file. And then to use a specific color in your app, you can add a colors object to this theme.extend section. So the keys of this object will be the color names, and the values are the color values. So we'll first define a primary color, and then we'll have this be a specific hex code. And then we'll define a light version of this, and we want this to be this hex code. So now we've defined these two colors for our app, so we can use these colors anywhere in any Tailwind class that uses a color. So let's come over to our root route now. And start styling our navbar. So to start, let's first wrap our links in a UL element. And then let's wrap each link in an LI element. So wrapping the links in a UL and an LI just communicates to accessibility tools a little better that these links form a list. All right, so now that we have our links defined in a list, we're going to put the navbar on the left side of the screen. And then we'll have the links stacked on top of each other. So to achieve this in CSS, we can display the UL element as a flexbox in the column direction. And with Tailwind, this just looks like flex, flex, col. Now let's get the navbar to take up the full left side of the page by coming up to our body tag and adding a class name of flex h-screen. And then down here in our navbar, let's add some color to it. So we've colored the background our primary color and made the text white. Now, just so you know, moving forward, I won't explain what every Tailwind class does, but if you're using VS Code, there's a nice extension here you can use called the Tailwind CSS IntelliSense extension. And with this installed, you'll be able to hover over any Tailwind class name and see what CSS corresponds to that class. So as long as you know CSS, you can easily see what the Tailwind classes are doing. You can also use Tailwind's awesome documentation if you're ever not sure about how to do something in Tailwind. And their docs can be found here at tailwindcss.com. And here's the docs section of their website. Now coming back to our app, we see that our navbar now lines the left side of the page. It's green, and the links are stacked on top of each other. In the next lesson, we're going to replace the text here with some icons. So right now, each link in our navbar is just some text, but in this lesson, we're going to change them to icons. Let's start by creating a icons file in our components folder. And this is where we'll put all the icons we need for the app. Now, in our app, we're going to use icons from Hero Icons, which was created by the makers of Tailwind. If you want to use an icon in here for React, just hover over the icon you want to use and click Copy JSX, and then paste that wherever you need it in your React app. Now, for convenience, I've attached a file to this lesson containing all the hero icons we'll need in the course, so you can just copy and paste the contents of that file into the icons file. So let's just paste those in. And now we have our icons. So now let's go back to our root route. And then let's replace the text in each of these links with the appropriate icon. Back in the UI, we see that the icons are now being displayed here in our navbar, but they're all kind of smushed up against the left side. So to fix this, we'll need to apply some styles to each of the links in our navbar. Now we could just repeat the same styles on every link here, but to make this a little easier, we'll just extract all of this to a custom component. So down here at the bottom of our page, let's create a new component called app_nav_link. And then let's just copy and paste one of these links in here as a starting place. Now to make this component reusable, we just need to make it accept a couple props. So let's make a type for the props first. And the two things that we'll need as props are the children, which is of type react.reactNode, and then to, which is a string. And then let's grab those props down here. And then we can use those props down here in our UI. So to will just be equal to 2. And then children will go right there. Now back up here in our app component, we can just replace each of these links with our new app_nav_link component. So now down in our component, we can apply some styles. So first on here, let's add W-16, and this will just set the width of each link to 4 rem. And then let's wrap the children in a div. Now this div will have the class name py-4 flex justify center. Next, we want to make the links change color when we hover over them. And to do this with Tailwind, we can just use the hover directive and then say we want the background to be our primary light color. And then finally, let's come up to our outlet right here and wrap that in a div and give this div some padding so that the content of the nested routes to the right of the navbar isn't like smushed up right next to the navbar. So back in the UI, we see that our navbar looks quite a bit better. And as we hover over the links, they change colors and we're able to navigate between pages. Cool. So in the next lesson, we'll wrap up this section of the course by making a few final styling adjustments to this page. All right, in this lesson, we're going to finish up this section of the course by making a few styling adjustments to the navbar. First, notice how when we click on a link and then move our mouse, the lighter background color doesn't stay. This makes it difficult to tell which page we're currently on. So we could give users a better experience by making the current active link stay that lighter color. To make this happen, let's go into our root route and find our app_nav_link component. And in here, we can change this link to a nav link. This navlink component comes from Remix, and it's aware of which page the user is currently on. So it allows us to easily apply different styles to the link when it's active. We can get the active state of the link by rendering a function as the child instead of just another element. So we'll say a function here, and then this function will return what we're currently rendering. Now this function receives an isActive prop. And so that's how we can apply different styling depending on if the link is active or not. Now to facilitate conditional class names here, let's install a little helper function with npm I class names. Now on this div, we can say class names from the class names package. And then we can conditionally apply the bg primary light class if the link is active. So that's how this function works. You can pass a list of class names as a string, or you can pass an object with a class name as the key and then the condition as the value. So whenever it's active, this class will be applied. Now, if we come back to the UI, we can see that we are on the Discover page and the Discover link is highlighted that lighter green in the nav bar. And if we click around, we see that we can always tell which link is the active one. The next adjustment we're going to make is to make the nav bar work a little bit better on mobile device screens. So I'm using Chrome here, so if I inspect the page, I can click on this little icon right here to see what the page looks like on a mobile device. Now, a mobile device is taller than it is wide, so having a nav bar on the left side is a little bit awkward. I think it would be better to put the nav bar across the top of the page on mobile screens. To make this happen, let's come up to our body tag. Right now, the body tag has these flex and hscreen classes. And these make the nav bar appear on the left of the main content. Now we can tell Tailwind that we only want to apply these class names on medium or larger screens by prepending each class with MD:. So what do we mean by a medium-sized screen? Well, if you hover this, you'll see that it applies a media query in the CSS for screens where the min width is 768 pixels. So that means that the hscreen and the flex classes will now only be applied if the screen gets wider than 768 pixels. We also need to come down here on this UL and make sure that we only apply the flex call class on medium and larger screens. And that's because on medium and larger screens, we want these links to be displayed in a column. But on smaller than medium screens, we don't want them in a column. We want them in a row across the top. So back in the browser, we're on this mobile view, and we can see that the nav bar is now across the top of the page. And if we come out of mobile view, then it goes back to the left. All right, that wraps up this section of the course. In the next section, we're going to learn about data loading in Remix. In any app, there will come a point where you need to load data from somewhere. Could be a database, a third-party API, or even a file. In Remix, the primary way to get data from any source into your app is with the route loader export. Here's a visualization of what I mean. Any data that you want to bring into your app comes through the loader. Let's do an example. Let's open our settings route And then here, let's export a loader function. Now, from the loader, we can return an object, and let's put a message in that object. Now, we can read this data down in our component with the useLoaderData hook. And loaders play well with TypeScript, so we can get the type of the loader data by passing typeOf loader as a type argument to the hook. Now down here, we can render the message from the loader. So now let's go back to the app, and let's go to the settings page. And here you'll see that message from the loader is being rendered on screen. Let's take a deeper look at this in the Network tab. The first thing I want to note is that if we refresh the page and then look at the document request, we can scroll down in the preview and we can see that the message from the loader is already there. So this is because Remix has server rendered the page, and the server render includes the loader data. Now, the second thing to note is if we clear this out and leave and then come back, this time we arrived at the settings page via client-side routing. So instead of doing a full document request, Remix just fetched the data from our loader in this request right here. Now the format of this response is a little bit strange, and it's not a format that one would easily recognize like JSON. Remix uses this response format when it calls your loaders from the client so that you can stream more complex data from your loaders than just JSON types like strings, booleans, and numbers. So for example, we can actually stream a date object to the client like this. Let's say date and then new date. And then let's make it a specific date, say January 1st, 2025. Now on the client, we can render the date. And notice how the type of the date attribute here is a date object. So we can call .toString on it to render the date. Now it's really easy to miss how cool this is. The loader, which is a function that runs on the server, is able to transmit a date object across the network to your component. So if we come back to the app and leave and then come back, we'll see in this data request that Remix has serialized the date object down here in the response. Now, dates aren't the only object type that you can stream from loaders. You can also stream errors, maps, promises, regular expressions, sets, symbols, URLs, and more. The fact that we can stream promises in particular is really cool, and it enables some performance benefits and better UX in certain situations, but we'll discuss that more a bit later. For now, let's just come back and remove the date from the loader. And we'll just keep the message in there for now. Whenever you're loading data from external sources into your app, you'll likely need to display some pending UI to the user as you wait for the data to load. To illustrate this, let's go to our app and throttle our network. I'm going to choose 3G here. This allows us to simulate a slower network to see what the user experience is like when the app isn't running at full speed. When we navigate to pages besides the settings page, it loads pretty quickly. Sometimes Remix has to make a request for some code because it lazy loads your code for each route. But once that's loaded, the transitions between all these three pages are fast. However, when we go to the settings page, it has to make this request for the settings data, and that takes a minute. So even if we come off and then go back, it's going to take a minute to load. Remix doesn't transition to the settings page until this data has returned, because it needs that data in order to render the settings route. This means that the user is left in kind of an awkward state, where, say they're on this page and then they click on the settings, it kind of feels like nothing's happening. Then suddenly after a second or two, they're taken to the settings page. So to let the user know that we're just waiting on some data to load, we can add some pending state to the UI. This way, the flow will be click, then see the pending UI, then navigate to the settings page. It'll be a much better experience for the user. Now we're going to implement some pending UI in a couple different ways, and we'll get started in the next lesson. The simplest way to implement pending UI in Remix is to let the browser take care of it. Browsers come with built-in pending UI via the icon in the tab. You've likely noticed that when you first load up a web page. The icon turns into a loading indicator until the page is fully loaded. The important thing to understand about this loading indicator in the tab is that the browser only shows it for document requests. That is, when the page is being refreshed or a new page is being fetched. So when you first go to the site, the browser shows it. If you refresh the page, the browser shows it. As we navigate around, though, the browser does not show the loading indicator. And this is because these links are implemented with the navlink component from Remix, which does client-side routing. So in other words, these links do not initiate a full document request, as we've seen already. Instead, they just initiate data requests if there's data to get. We can make the links on the left nav bar do a full document request by coming into the root route here, going to our app navlink component, and then simply adding reload document as a prop to the navlink. So this tells Remix that when you click on one of these links, it should do a full document reload rather than do client-side routing. So if we come back to the app and click, we'll see that that loading indicator up in the tab always gets shown. So this is a lot better for the user because once they click on something, they can see that the page is actually working on getting the data that they requested. Now, it's cool that the browser comes with built-in pending UI, but it's even cooler if we can build some custom pending UI right into the UI of our app. So that's the approach we'll look at in the next lesson. So we've learned how to create pending UI with the browser's built-in mechanism in the Browser tab. For a better user experience, we can create our own custom pending UI. Remix comes with a hook called useNavigation to help us do this. The result of this hook tells us everything we need to know about the current navigation happening in the app. Specifically, we can use this navigation object to determine if Remix is loading the next page. So let's create a variable called isLoading. And now if Remix is loading some data, the state property on the navigation object will be equal to loading. The navigation object also keeps a property called location, which is a location object and contains information about the URL that Remix is navigating to. We only want to show this link in a pending state if Remix is in the loading state and it's navigating to the page represented by this link. So we'll say and navigation dot location dot path name equals 2. So like I said before, this is a location object, and the path name gets us the URL path name. Now the only problem with this is that the toProp here is a relative URL path, and the location path name is the full URL path. So we need to get the full path represented by the relative path from the toProp before we can accurately compare them. Remix provides another hook for this called useResolvedPath. And we'll just pass the relative path to the hook, and then we'll get the full path here. Now this is a path object, so down here we need to say path.pathname. So if isLoading is true, then we need to show this link in a pending state. So let's say animate pulse is loading. And we'll also want to turn the background light if it's loading as well. So the effect of this is that the link will pulse between the regular background color and the light background color when it's in the pending state. We also want to remove this reload document prop here so that we don't reload the whole document when the link is clicked. So let's come back to our app. Let's throttle the network. And then let's navigate to the settings page. You see that we get that pulsing animation while the route is loading. Once it's done loading, we're transitioned to the new page. So up until now, we've simulated a slow loader response by throttling the network in the browser. But what if the slow response isn't because of the user's network, but because your loader is slow? In our settings route, let's simulate this by returning another message from the loader wrapped in a promise and a set timeout call that waits for 700 milliseconds. So now, even if we turn off throttling, so we're on a fast network, when we navigate to the settings page, it takes 700 milliseconds to load. Our custom pending UI still works, but it's frustrating because the slow response is our own fault this time. Now, the first thing to try in this scenario is always to optimize your code. And I want to stress this. Pending UI isn't the solution if you can just speed things up. Find whatever is making your code slow and then try to fix it. But let's assume that you've tried and you're just not able to speed it up. It's kind of annoying that the entire page becomes slow to load because of this one slow message, even though this other message is fast. It would be nice if we could load the rest of the page quickly and then render the slow message later when it's ready. Remix gives us this ability. So over here in our loader, instead of awaiting this promise, we can just return the promise in our loader, since Remix is able to stream promises across the network. Now in the UI, this is of type promise, so we need to await it in the UI. And we can do this with React Suspense. So to explain what's going on here, React Suspense is a component from React that will render this fallback component until its children are ready to render. The await component comes from Remix, and it's what awaits the promise that was streamed from the loader. We tell it what promise we want to resolve, and then it gives us the resolved value here in a function so that we can render the UI. So back in the browser, if we navigate to the settings page, we'll see that it loads immediately, but the slow message gets rendered later, and the fallback UI is shown in place of the message until it's ready. This is pretty nice because we're able to show the user the page immediately and then just wait for the slow parts until they're ready. There is one small hiccup here though. So if we navigate between the app and profile children routes, we'll notice that they also take 700 milliseconds to load. And this is because Remix calls all loaders on the page for every navigation. So we're refetching the slow message every time we navigate between child routes. We need to tell the React Suspense component to re-render itself every time the path name changes so that we can display that fallback UI here again and display this content immediately. We can tell React to re-render the suspense component whenever the URL changes by first grabbing the location object and then passing the location path name as a key to the suspense component. So now, whenever the path name changes, React will re-render the suspense component, so it will display this loading UI again, and it will re-await the promise. So now, back in the UI, we can freely navigate between child routes, and the slow message goes back to the pending state every time we do. So loading your data before a route transition might feel weird if you're used to building single-page applications. With single-page apps, you're probably used to fetching data in your component and showing a spinner in place of the UI while the data loads, and then switching that spinner out for the regular UI once the data has finished loading. But as we saw in the last lesson, Remix fetches all of your data before your component loads. So before we transition to the new route, Remix is fetching your data. And then it transitions to the new route once it has all the data needed to display the new page. I think Remix's approach here of loading data before the transition is a lot better than the traditional approach of loading data after the transition for a couple reasons. So reason number one is that the user can just keep doing what they're doing while the new page loads. The user is only taken to the new page when it can be completely rendered immediately. So in our app, when we're on a different page and we want to go to the settings page, we can still see the content of the page that we were on previously before transitioning to the new page. And I would say that having something to look at, even if it's the old page, is a lot better than just staring at a blank screen or a loading spinner while you wait for the new content to load. So with Remix's approach, the user never has to do that. They never have to stare at a blank screen, and they never have to see a loading spinner on the new page. They can just look at the old content and just wait for the new page to load. And then once it's loaded, boom, you have all the content immediately. The second reason that Remix's approach is better is separation of concerns between your UI and your data. So React is really good for building user interfaces. In fact, if you go to the React homepage, that's exactly what it says here. React is a JavaScript library for building user interfaces. What React isn't very good at is loading data into your app. React needs to show data, but it really shouldn't be responsible for fetching that data. Fetching data is not a concern of your UI. So here in our settings route, we clearly have separation of concerns here. We have the loader, which is responsible for loading data, and then the React component is responsible for just displaying that data. It doesn't have to think about where it's going to get that data from. Remix just calls the loader and hands your component the data, which is really nice for developer experience. The third reason is that loading data in a loader instead of in your components makes your app much faster. So consider this simple example I have here. We have an app component at the top level, and that renders a notes component below it. So in the app component, this would just be a fetch call to fetch the user. And so we would check if the user is loading, you'll render a spinner. Then if it's not loading, we'll render the regular UI. But notice here that something kind of sneaky is happening. So because we render the spinner while this is loading and we don't render any of this, the notes component, which down here loads a list of notes, the notes component can't even start fetching that until the app component finishes fetching the user. So once this is done, then finally the notes component renders. And it's at that moment where the notes component can start fetching the notes. And then it in turn will display a spinner. And then once the notes are loaded, it'll display all those notes. So this is what we refer to as a waterfall. And it makes your app a lot slower than it needs to be. So what we're seeing in that example, here it is represented visually. If your app takes 3 seconds to load the user, and then your notes takes 3 seconds to load the notes, that's a total of 6 seconds for the page to render completely. Now, if you were to load them both in parallel, they could both still take 3 seconds, but since you're loading them at the same time, your total time for rendering the whole page is 3 seconds. Now, Remix allows you to do this. Remix allows you to fetch all the data for a whole page all at once. So that speeds up your app a lot because you're just fetching all the data for the whole page before you even render any of it. And then once it's all loaded in parallel, you finally display the whole page. Just to give you one more example of this, Remix has a great example on their website. So without Remix, you get this user experience over here where you load something and then it displays a loading spinner and then it displays something once that's done loading, but then that renders the nested component, which starts loading something else. You get another spinner and then you display that content. Then you get more loading, more loading, more loading, all the way until the app is finally loaded. So you can see just how long this took to load. Meanwhile, with Remix, it was doing all that loading in parallel. So if we scroll back here, you'll notice we just don't see anything, but then all at once, boom, the whole page is loaded because Remix fetches all of your data in parallel. We can see an example of this in our own app as well. So if we come over here to one of these routes that's nested below the settings, and we add a loader in here, and we'll display that data. So now when we go to the profile route, we're calling data for the profile route, which displays this message here. So let's go and change this link just for demonstration purposes. Let's change that link to go directly to the profile page. So up here, we'll do to settings/profile. Refresh our app. Now, let's clear this out. And if we're on a different page and then we click this, which is going to take us directly to that settings profile app now, notice that we get two data requests here, loading in parallel. So one of these is the loader data for the settings route, and then the second one is the loader data for the settings profile route. So this is the benefit of putting data needs in loaders instead of in your components. Remix can extract all your loaders at build time, and so it knows your data dependencies ahead of time. That's why when you go to a page, Remix already knows, oh, I'm just going to call all the loaders that are about to be displayed on this page. So it calls them all in parallel, and you get all of that data loading all at once, which speeds up your app a ton. But since that was just an example, let's go ahead and revert these changes. So we'll go back to regular settings, and we can leave this loader data here. So in this lesson, we learned about why Remix chooses to load data before the route transition instead of in components after the route transition. It provides a better user experience for the user. It separates concerns between displaying data and loading data, which makes a better developer experience for you. And it makes your app a lot faster. So in the next lesson, we'll dive deeper into use loader data and how it works and how we can share loader data across routes. In this lesson, we're going to learn about error handling in Remix. When building an app, a lot of things can go wrong. For example, let's go to our settings route, and let's say we made a mistake here on accident. Instead of data.message, we said data.values.message. Now, thankfully, we're using TypeScript, so we would never actually make this mistake, but let's roll with it. So we made an error in our code, and now let's visit the settings route. When we visit this route, we see that Remix provides this default error UI for us. It shows the error message and then the stack trace. This UI that we see here is because over in our root route, we have an error boundary component. Whenever something goes wrong in your app, Remix will find the nearest error boundary in the route hierarchy and render that UI instead of the default UI. Any route can export an error boundary component. So we could export another error boundary in our settings route. Let's do that down here. We can grab the error in the error boundary component in a couple ways. First, we could use a hook. And this hook is called useRouteError. The other way we can get the error is through props. So we can say error, and then the type of these props comes from the generated types. So Remix generates types for us, and we can import that from the appropriate plus types directory. So we'll say import route from plus types / settings, since this is the settings route. And then these would be the error boundary props. So that's the second way that we can get the error. Once we have the error, we can render a new error UI. Now we're getting a TypeScript error on this error object, and that's because this error could technically be anything. It's of type unknown. In Remix, you can throw error objects, but you can also throw other things like strings or other objects or any other value. So we need to type check the error here. If the error is not an instance of the error type, then we'll just return a generic error message that says an unexpected error occurred. So now when we visit the settings page, we see our custom error boundary from the settings route. Now what's really cool about error boundaries, as you can see, is that only the UI for the route that had the issue gets replaced with the error boundary. All of the parent routes still render normally. This allows you to have very granular control over how errors are displayed in your app. Each route can export an error boundary, and that error boundary will be used for errors in that route, or any routes below that one if they don't have error boundaries defined themselves. This is why before we defined this error boundary, we saw the error boundary in the root route, because that was the nearest error boundary in the route hierarchy. Now again, thanks to TypeScript, we would never actually make this error, so let's fix that. But we'll leave the error boundary in place just in case anything else ever goes wrong in this route. So in this lesson, we're going to install Postgres on our system. Now there are a couple different ways you could install Postgres. The first way is you can just go to Postgres directly, and you can follow their instructions here to download Postgres on whatever operating system you're on. I would just download the most recent version if you're going to do it this way. In this lesson, however, we're going to install Postgres using Docker. So if you're not familiar with Docker, Docker is a piece of software that allows you to run containers on your computer. And so what is a container? Well, you can think of a container as like a bundled package of software that can stand alone and contains everything that an application needs to run. So, for example, you might have your computer, your laptop, and on your laptop you could have one or more Docker containers. And so, for example, if you wanted to run Postgres in a container like we're doing, you could run a Docker container that contains Postgres, but it also is going to contain an operating system and any dependencies that Postgres needs in order to run. So Alpine here is an example of a lightweight Linux distribution. You could have another container running. Maybe this one has Ubuntu on it and it's running Node, and maybe you have a Node.js app running in there too. Same down here, but on a different operating system back on Alpine. So Docker basically lets you run different applications in like a standardized environment. And so you don't have to worry about installing the software yourself on your own machine or installing all the dependencies of that software, because the container just kind of bundles everything that the app needs to run. So this is also really nice in situations where you want to develop locally in the same environment that you deploy to. So you can also deploy Docker containers. And if you're developing using the same container or the same image, an image is like all the instructions for how to set up the container. So if you develop with the same image or same container as you deploy to, then you're not going to have weird inconsistencies because you develop on Windows, but you deploy to Linux or whatever it might be. If any of that sounds confusing, I wouldn't worry about it too much. You don't need to understand the ins and outs of Docker and how it works in order to follow this guide. If you're curious, you can always read up more on Docker, but you don't need to understand it super well in order to follow this. So let's go ahead and search Docker. We'll come here to this Get Docker link. And Docker has different instructions for installing Docker depending on your operating system. If you're on Linux, Docker's a little bit weirder to install and use. I might just install Postgres directly if you're on Linux. But if you're on Mac or Windows, they have instructions here for downloading their Docker desktop application, which comes with Docker command line utilities and also a nice user interface to see all your containers. So since I'm on a Mac, go ahead and click this one. You can download Docker whether you have an Intel chip or an Apple chip. As a system requirement here, have to be on version 10.15 or newer. And then they have instructions down here of how to install it and everything. So, and then same over here, if we go back to Windows, different system requirements again, 4 gigs of RAM, 64-bit processor, at least Windows 10. And then, so you can click this and install that down here, follow these instructions to install Docker on Windows. I'll go back over here, desktop for Mac. I'm using an Intel chip, so I will click this. Go ahead and save that. And again, if you're not on a Mac, don't worry too much. Hopefully this process is pretty similar. I imagine you just have to install the executable like I'm doing here and then just run it in. So once this is done downloading, it might take a while, and go ahead and click this. And then if you're on Mac, all you have to do is drag and drop this to your applications folder. Now I already have it installed, so I'm not going to drag it there again. But once you drag that there, then you will have Docker installed on your system. And so to run it, you can just search for Docker, and you should see a little Docker icon up here in the top. And then if you open the app, you should see this. And so this is Docker Desktop. I already have a few containers running here, so we can ignore all those. you will probably see nothing here if you're installing Docker fresh. This will be all blank. So now, once you have Docker installed, you can come back over here to our app. And so it's pretty easy to get Postgres running with Docker through the use of a Docker compose file. So we're going to go ahead and do Docker compose.yaml. So this is a YAML file. And so I'll just walk you through each of the steps here. So it's not anything too complicated, but so the first thing is we want to say services. So this defines all the services that we want to run or containers that we want to run when we run this Docker compose file. So you can run multiple containers at once. We're just going to have one though. We're just going to run Postgres. So the next thing is give your service a name. So we'll just call it Postgres because this container is going to run Postgres. Then the next thing to do is to tell it what image you want to use. So an image is basically pre-built instructions on how to run whatever container you're trying to run. So Postgres has an official container in order to run Postgres, and that container is called Postgres. And then we just want to get the latest. So the first part of this is the name of the image that you want to use, and then this is a tag, so you can create like different versions of images, and we'll just say latest in this case. So then we want to set up our environment, so this will be like the Postgres user and the Postgres password and the name of our database. So we'll call it environment. So here we just say the name of the environment variable. So Postgres requires that you define a couple variables. So we'll define Postgres user. And so the Postgres container is going to use this to determine what the username is that we'll use to connect. So we'll just say Postgres is our user. Then the next one is Postgres underscore password. So this will be the password to log in to our Postgres database. And we can just call that Postgres again, just to keep it simple. And then down here is the name of the Postgres database. So, and we can just call this Postgres again. So a Postgres database with the user Postgres whose password is Postgres, and the database is named Postgres. A lot of Postgres, but those are the only environment variables that we need to create. So then the next thing is ports. So because containers are like isolated packages of software, we have to tell Docker to map the port that Postgres is running on inside the container to our actual machine. So Postgres runs on port 5432, and then we want that to map to 5432 on our machine, so we can access it at localhost 5432. Again, if that doesn't totally make sense, don't worry about it too much. And then the last thing is volumes. This is just going to define the folder that we want this container to store all of its data in. So we can just say we'll just store it in a local folder here in our app called Postgres data. And then that's going to map to a folder inside the container, which is where Postgres stores all of its data by default, which is called var lib postgresql/data. So again, if that doesn't make total sense, don't worry about it too much. But basically, we're going to store our Postgres data in a folder called Postgres data here in our app. And that's all you have to do to tell Docker how to set up our Postgres database. So then in order to run that, just come down here and do Docker compose up, and then we'll do -d. And so this compose up command is how you run this file. And then -d just means that we'll detach from it in this terminal. So we don't get like outputs and logging in this terminal. It will just run it in the background, basically. And when you installed Docker before, it should have installed this Docker command. So go ahead and run that. We actually want one more thing in this file. So this is just a setting to tell Docker to always restart this container if it ever shuts down for any reason. So this will just make sure that it's always running in the background. So we'll say restart, and it will just say always. So that's the value that Docker expects if you want it to always restart. So once you have all those, that's all it takes to get Postgres set up on our system. And so to run Postgres, we'll just run this file with a command called docker compose. And so when you install Docker, it should have installed this command as well. So we'll say docker compose up. And so that's how you run this file. And then we'll do -d. And so that's going to detach the process in this terminal. And so it'll just run in the background. So do docker compose up -d. It'll tell you it's creating our container. Now it's done. You see that we have our Postgres data folder created here with a bunch of Postgres stuff in it. We're going to want to ignore this in Git. So let's go ahead and come into our .env file. If you don't have this, go ahead and create it. So let's come into our git ignore file, and we'll just add Postgres data. So that'll ignore this whole folder because we don't want to push all that stuff up to Git. We don't want to store our data in GitHub. Okay, so if you come over to your Docker desktop UI, you'll see that we have Remix Recipes, which is the name of our app running. And then in there, we have our one service, which is our Postgres container. That's running locally on port 5432. And so that is all it takes to get Postgres up and running with Docker. So in the next lesson, we are going to set up Prisma, which is our ORM, or Object Relational Mapping software, that will allow us to connect to our Postgres database from our Remix JavaScript code. In this lesson, we're going to set up Prisma in our app. If you don't know what Prisma is, it's an ORM, or an Object Relational Mapper. And if you don't know what an ORM is, it's a piece of software that allows you to interact with a database through code in whatever language you're using. So instead of writing SQL queries yourself, you can just use the ORM to talk to the database. ORMs are an abstraction for your database, and like any abstraction, they make a trade-off between productivity and control. ORMs are generally really great for basic database operations, but if you need to run more complex SQL queries, you're likely better off not using an ORM and just writing raw SQL. The queries we need to run in our project are pretty basic, so it makes sense to take advantage of the higher productivity that an ORM like Prisma offers. In terms of where an ORM fits in your stack, it sits between your backend code and your database. So, as we've talked about already, Remix runs on both the client and the server. So our remix code is our backend code. And then Prisma sits between our backend code and the database. So we communicate with the database through Prisma. There are a couple things I want to note about Prisma specifically. Prisma consists of two parts: the CLI, or command line interface, which is the Prisma package, and the Prisma client, which is the @Prisma/client package. The @Prisma client package is what we use in our code to talk to the database. And the cool thing about Prisma is that it generates code that is tailored to your specific database schema. And it puts that tailored code in this Prisma client directory. So this is how Prisma is able to achieve type safety with TypeScript and give you a great developer experience that's tailored to your schema. So every time we change our Prisma schema, Prisma will run this generate command and regenerate that custom code so that the Prisma client is always tailored to our needs. So let's get started setting up Prisma. The first thing we need to do is install those two packages we just talked about, Prisma and Prisma Client. So since Prisma is a command line interface, we don't need it in production, and so we'll install it as a dev dependency. And then we'll install the Prisma client as a production dependency because this is the package that we'll actually use in our code to talk to the database. So now that we have those installed, we can use the Prisma CLI by running npx prisma init. This is going to initialize Prisma in our project. And we also want to pass this data source provider flag. And since we're using Postgres, we want to tell Prisma to initialize everything for a Postgres database. So this command did a couple things. So one, it added a database URL to our .env file. And this database URL is a Postgres standard, which specifies how you connect to the Postgres database. So it starts off with this PostgreSQL, which is the protocol that we're using. Then this first part here is the username. And if you remember over in our Docker Compose file, we set the username to be Postgres. So we can go ahead and change this to Postgres. Then we set the password to Postgres as well. So we'll change this password to Postgres. This part of the connection string specifies where the database server is running, and we are running it locally on port 5432. So we don't have to change this part. Then this part is the name of our database. And over here in our Docker Compose, we named our database Postgres. So we'll replace this with Postgres as well. So Postgres, Postgres, Postgres. This last part specifies which schema to connect to. And so in Postgres, a schema is just a collection of database tables. And by default, Postgres has a schema called public, which all users have access to. So we'll just leave this default schema as it is. The other thing that the Prisma init command did is it created this Prisma folder with a schema.prisma file inside of it. So there's only a couple things in here at the moment. This first part, the generator. So this first part, the generator, this provider field specifies the package that the Prisma CLI uses when it generates this custom code as part of the Prisma client package. And then this data source DB section here tells Prisma how to connect to our database. So this provider field tells Prisma that we're using a Postgres database. And then this URL is that URL connection string, which tells Prisma everything it needs to know in order to successfully connect, including the username, password, and database name, just like we set up back over here. So in this lesson, we set up Prisma and our app. In the next section, we're going to start building out the pantry page of the recipe app. In this section, we're going to build out the pantry page of the app. This page is for storing and organizing food items that you have so that the app knows what recipes you can make. This is what it will look like when we're done. Each of these sections is a shelf. Shelves have a name, and you can add and remove items on each shelf. Let's go over the features that we'll be implementing. The first is the search bar. You can type in a query here, hit enter, and the shelves will filter down to the ones that match your query. Let's create a new shelf. Shelves start out with the name new shelf, and then you can change that by updating the name. That new name automatically gets saved as you type. We can also add items by typing in this new item input here. Once you hit enter, the item appears down below. If we add more items, they show up in alphabetical order. And clicking the trash icon lets you delete them. We're also going to add some optimizations for users on slow networks. So for example, if we open up the network tab and slow this down to slow 3G, we can add items, and once those items have been saved, the delete button shows up, and then we can delete them. So adding and deleting items feels really snappy even when your network is slow because of something we'll implement called optimistic UI. Finally, we can delete the shelf. When we click delete, it asks us if we're sure. We click OK, and the shelf disappears. So we'll get started building all this in the next lesson.
Nice work. You've taken your first step into React Router, but what you've learned here is just the beginning. In the full course, you'll go much deeper and build a full stack recipes app. Add auth, handle forms and uploads, create complex UI flows, write end-to-end tests, and deploy to production. Or you can become a member of the Zero to Mastery Academy, where you'll not only get full access to Zach's entire React Router Bootcamp course, but also every other ZTM course, and priority support from our world-class instructors and mentors inside our private community. If you enjoyed this crash course, please drop it a like, leave a comment, and maybe share it with someone that wants to build better React apps. Thanks for watching, and I'll see you inside the Zero to Mastery Academy.